Hi students, this is Naveen. Today we are going to solve this problem and come to the problem. A condenser. First, what is meant by condenser? Condenser is nothing but capacitor. Capacitor and condenser both are same. Remember, here a condenser having a capacity of 6 microfarads. They are given one capacitor having the capacitance, let us assume C1, already given 6 microfarad. It is clear? It charged to 100 volt. We can written as, let us assume that is V1. V1 is equal to 100 volts and is then joined to an uncharged condenser. It will join to another condenser. I will take one more capacitor here because condenser and capacitor both are same. Another condenser. This condenser capacity, how much given? C2. Let us assume C2 is equal to 14 microfarads. And here that is uncharged. Uncharged means we can directly write. I can directly write Q2 is equal to 0. You know that Q is equal to CV. And C2 is equal to 14, Vt is equal to 0. I can directly write Qt is equal to 0 because that is the uncharged capacitor. Coming to this one, here the charge Q1 is equal to, you already know that Q is equal to what the formula? C into V. Q1 is equal to C1 into V1. What is the C1 here? 6 into micro means 10 to the power of minus 6 multiplied by 100. What I got? 600 microcoulombs. It is clear? This is the first capacitor charge. This is the second capacitor charge. Now, what they are asking, if those two capacitors are joined together, if the two capacitors, the first capacitor C1 and second capacitor C2, if these two join together, what will happen? Remember, if the two capacitors are joined like this, what will happen means, according to law of conservation of charge, the initial charge must be equal to final charge. According to law of conservation of charge, Q initial is equal to Q final. Whenever both are connected, what will happen? Q initial is equal to Q final. What is the Q initial? Q initial is nothing but, say, right, Q1 for the first capacitor charge, Q2 second capacitor charge is equal to Q, where Q is the final charge, Q1 is the initial charge of the first capacitor, Q2 is the initial charge of the second capacitor, Q is the final charge of those two capacitors whenever those two are connected together. It is clear? And we know that Q is equal to C1 V1. I can write C1 V1 instead of Q1, C2 V2 instead of Q2. And what about Q? Total capacitance, shall write C into V. What is the C1 V1? You already know that 600 microcoulombs. C2 V2 0. What is the C here? Both are connected in parallel. In parallel, if you connect the two capacitors, means the total capacitance C is equal to C1 plus C2. What is the C1? 6 microfarads. C2 14 microfarads. Here I got 20 microfarads multiplied with V. How can I write? From this, V is equal to 600 microcoulombs by 20 microfarads. Here, what I got? 600 by 20, it will become 30. Therefore, V is equal to 30. Nothing but here, what is the V? V is the common potential. Let us assume this is V. V is the common potential of the two capacitors whenever the two are joined. Here I can write common potential is 30 volts. It is clear? Now here, if those two are parallelly connected, the voltage is same. That's why we can write common potential will be 30 volts. Now what you have to find out, what they are asking, the potential of 6 microfarad will be. And you have to find out the ratio of the charges. First, after connection, we will get 30 volts. After that, if you remove the two capacitors, if you separate the two capacitors, first, initially, two are individually placed, the charge will be 600 microcoulombs, here charge will be 0. After that, we will connect the capacitors. After that, we have to remove the capacitor. While we are removing the capacitor, here C1 is equal to same 6 microfarads, common potential nothing but V is equal to 30. What is the voltage? And here C2 is equal to 14 microfarads. V is equal to, here also same 30 volts. Both are coming in parallel. Potential difference nothing but voltage between them is same. From this, Q1 is equal to C1V, Q2 is equal to C2V, Q1 is equal to 6 into 30. What I got? 180. 180. For the 6 microfarads, I can write here 6 microfarads and 30 volts. I got 180 microcoulombs. Here Q2 is equal to 14 into 10 to the power of minus 6 multiplied by 30. I got 14 3 42, 420 microcoulombs. Finally, I got after separation, the Q1 of the first capacitor will be, this is after separation. Remember, this is after separation, this is before separation, this is whenever the two are connected, you will get the voltage. Here after separation, Q1 is equal to 180 microcoulomb, Q2 is equal to 420 microcoulomb. What we have to find out? The ratio of the charges. The ratio of the charges, the ratio of charges. The ratio of your charges, how to write? So write Q1 by Q2, 180 by 420. If you cancel, it will become 18 by 42. See, 3 6 14 now. The ratio of the charges becomes 6 by 14, nothing but Q1 by Q2 is equal to 6 by 14. Finally, you got the ratio of charges, Q1 by Q2 is equal to 6 by 14. The potential, the common potential is equal to 30 volts. And here, before that, we are finding the charge on the first capacitor, charge on the second capacitor. It is clear? They are giving the two capacitors separately. One capacitor having the voltage 100 volts, another capacitor that is uncharged, that will be 0. After that, both are connected, we will getting the common potential. After that, we have to separate the two capacitors. After separation, we are finding the Q1, Q2. This is after separation. After separation. After separation, we got Q1, Q2. Q1 is equal to 180 microcoulombs. Q2 is equal to 420 microcoulombs, and we have to find out the ratio of the charges. Q1 by Q2, we got 6 by 14. The ratio of charges 6 by 14 and the potential 30 volts. Nothing but this is the common potential. This is the potential for 6 microfarads as well as 14 microfarads. Now, what is the answer here? 6 by 14 and 30 volts. Option C is correct answer. Thank you all of you. Thank you.